Hello everyone. Today we'll be looking at this integral here, which has many different types of terms. So the integral is x times arc sine of x squared all over the square root of 1 minus x to the fourth power. And of course, the integral is with respect to x. So the first thing I look at when dealing with these types of integrals is if I can kind of remove some items. For example, here we have a lonely x term, and I know that if we do a substitution, let's say with u equals x squared, then with the derivative that we do to switch from dx to du, we'll obtain a x term at the denominator, and this will enable us to cancel this. So we can start doing that. So we can say that u is equal to x squared, and that therefore du is equal to 2x dx, or dx is equal to du over 2x. We can therefore rewrite the integral as x arc sine of u over square root of 1 minus u squared times du over 2x. We can cancel these the x's right here, and we can rewrite this just to be clean as 1/2 times the integral of arc sine of u over the square root of 1 minus u squared du. Now, looking at all the residual terms, we see that they're all, this term is directly a trigonometric term. And this one, well, reminds us of a Pythagorean identity, right? So, or a Pythagorean triangle, which is kind of related to trigonometric identities. So what we can do, well, we can start just by drawing a triangle, right angle triangle, like this. We'll put an angle theta here, and we know that, well, this term here can't represent the hypotenuse of our triangle, because it's a square root of 1 minus u squared. So what I'll do is I'll put this term, so I'll put the following. We'll say that this is the square root of 1 minus u squared, and therefore the hypotenuse has to be 1, and the opposite has to be u. So what do we do with this? Well, we know that what we can say is that 1 over the square root of 1 minus u squared is equal to 1 over cosine of theta, or secant theta, right? That's the first identity we can find. Also, we can see that sine of theta is equal to u over 1, and that therefore theta equals arc sine of u. That's interesting because we have arc sine of u we have arc sine of u right here. And finally, we can see that sine theta equals u over 1. If we have a derivative of this expression on both sides, we'll find that cosine theta d theta is equal to du. And that, alright, so this is very interesting. So if we substitute all the terms we've just established back into our original integral here, we'll get that 1/2 times, well, arc sine u is nothing but theta, yes? So we have theta, and 1 over this square root of 1 minus u squared is secant theta, right? That's what we said here. So we can write this as secant theta, and du is nothing but cosine theta d theta. However, secant theta, cosine theta will cancel each other because one is the inverse of the other. And so what we get is this is equal to 1/2 times sec theta squared over 2 plus c. But what is theta? Theta is nothing but arcsine of u. So this is equal to 1/4 times arc sine of u all squared plus c. And what is u? U is nothing but x squared. So all in all, what we get is that the integral of x arc sine of x squared over square root of 1 minus x to the 4th dx is equal to 1/4 times arc sine of x squared all squared plus c. And that is the final answer. Thanks for watching. Subscribe to my channel, leave a like, and comment for any integrals you'd like to see in any of my next integral videos. See you.